Eric is a graduate student at University of Illinois, Springfield.
Thanks. All right. Well, good afternoon, everyone. Okay, it looks like we're set. So just a quick little disclaimer. I'm also work for the Office of Site Evaluation within the Illinois EPA. And some of the data collected in this presentation is reflective of data that we sampled through my capacity with the Illinois EPA. However, any determinations here are not reflective of the agency's position on anything. So anyway, so kind of some things to consider here with this particular project. Both state and federal regulations have been touched upon for PFAS, right? And, the state of Illinois right now is actively promulgating regulation for 6 different types of PFAS, which you'll see there on your left-hand side of the screen. Those are health advisory levels, which were numbers that I used for this project. And we're actively looking to adopt new groundwater quality standards. But in terms of modeling and investigative approaches that I kind of reflected upon before doing this project, considered kind of the use of geospatial methods and how those and geostatistical methods could be used and employed to showcase potential contamination pathways of PFAS within a given region, as well as the use of numerical models, groundwater models, such as ModFlow, and looking at data forensics, which is also a really novel, interesting pathway of analysis. So the particular site that this project is focused on is called the Sandy Hollow Groundwater Contamination Site. And that arose from a sampling event, a sampling inventory that the agency, the Illinois EPA, performed starting in late fall of 20. And in March of 21, the community water supplies located at the site, which is on the south side of Rockford, had some of the highest levels detected of PFAS within the state inventory, which was about 1,400 wells. And so it's also in a very interesting area because it's multi-jurisdictional and it is highly industrial, and it's a designated environmental justice area. And so in terms of timeline, as I kind of alluded to, after those 2 community water supplies were sampled, the Winnebago County Health Department and Illinois Department of Public Health sampled some private wells nearby. Approximately 10 private wells were sampled within 2021, and they proceeded to have the Illinois EPA and our office perform additional sampling in May of 2022, because those private well samples also all had detections above public health advisory levels. And so one of the considerations in designing the sampling methodology for this particular site was doing kind of a site file history within the agency's database and other databases we could access. So in terms of site characterization, had to identify potential sources of PFAS, which, as we know, there's a multitude to say the least. And so all the orange kind of polygons there were indicative of potential source areas within this 9 square mile area. And another consideration we had to kind of think about was geology as well. And this is a cross section, the purple line there, taken from a Superfund site nearby within the source area. And as you can see, it's kind of interesting. We have the bedrock as you move from right to left, dropping quite precipitously, about 300 feet or so as you get toward the Rock River itself. And we also have a shallow alluvial aquifer, as one would suspect in this type of setup. And on top of that, we have a till as well from the glacial deposits. And so some questions I had asked is kind of being curious about how geospatial methods can be used in this capacity, in this investigative capacity and how can they be validated. And the integration of these methods and how one can devise kind of an understanding of what's ongoing in this area. So data collection itself was performed in May of 22. There were 16 samples we had hoped to collect, but due to geology, we ended up collecting 12 additional samples from those 10 initial samples that were collected in 2021. And from those samples, we actually used a geoprobe system, screen point 16, to collect 7 grab samples. And we had a pre-existing monitoring well network from the Superfund site nearby. And so we also took 5 monitoring well samples from that site. Okay. And so this was some of the data we collected, kind of a synthesis of those different collection times. And so as you can see, we have proportional kind of intra and inter sample proportional concentrations here. The larger the circle, the larger the total amount of PFAS. And we were most concerned with 3 different types of PFAS species that had exceedances, and those were PFOA, PFOS, and PFHxS. So as you can see, we kind of had generally a hot area, if you will, where we had some of the largest detections of PFAS. And that was located near the intersection of 11th Street and Sandy Hollow Road. And also right in the area of that community water supply. The highest amounts of PFAS, the 3 different types that we had within this sampling regimen were 95 parts per trillion PFOA, 150 parts per trillion PFOS, and 200 parts per trillion PFHxS. Okay, and so then I employed inverse distance weighting interpolations to kind of see where potential sources could be, where things could be emanating from, perhaps. And so, as you can see from those 3 maps, I did it for each different type of constituent relative to the health advisory levels, and did notice that there was kind of some interesting paths to the, considering groundwater flow, potentially of PFAS emanating from the east-northeast or east-southeast, essentially more or less upgrading, as one would suspect, from our highest concentrations. So given that information, I also wanted to consider LiDAR. And this is kind of interesting. The blue is high ground. The white, I guess it's white on the end there, reddish white is low ground, and that's the Rock River. As you can see, we kind of have some deltaic, doesn't show up quite as well, but we have kind of some deltaic elements as we get close to the Rock River. And we have the green and yellow, which is indicative of the till, which is up gradient. So again, we kind of have that bifurcation, that divide between the glacial outwash and the alluvium. And so the black polygon there is the Southeast Rockford groundwater contamination site, which is an ongoing Superfund site. And so a lot of the data I employed for this project was obtained through US EPA and contractor-based data from that particular site. And last thing I'd like to point out on this particular map is you can see generally, like I said, considering kind of surface elevation, groundwater flow also is kind of reflective of surface elevation, because we have the yellow kind of nuke, if you will, emanating from the east here. And as you can see, the plume itself kind of generally follows the path of the topography, which is kind of interesting to note. And so I ended up overlaying some of the geospatial, the IDW interpolations again, and it was interesting how they kind of lined up with that groundwater flow path. But again, this was about a quarter mile south of that flow path, that the Superfund flow path. But I could kind of see that maybe there was something to kind of these little valleys, right? Kind of nooks that were coming out of the till into the river valley. And so kind of then again employed source ID and thought about, well, given what we know, what our potential source inventory is, which sources might be good to eventually employ a groundwater model to see what might line up with our actual data points. And so again, overlaid this potential sources identified with the LiDAR and ended up using Groundwater Vista's GUI interface version 6 and used ModFlow 2000 and MT3D as well in this interface, and employed the head data and no flow boundaries and LiDAR data as appropriate, as was outlined earlier, and retrieved hydraulic conductivity rates, head data, geology, and pumping data from the pre-existing Superfund site. Because this type of project, we had limited information. And so we had limited information, limited data, and a limited budget, as all of us face, right? So this is kind of a quick and easy kind of methodology I was looking to employ to see, you know, what areas might be susceptible, as well as what potential source, essentially a quick source ID for kind of limited information projects. Ended up discretizing the sand and gravel layer, which is a shallow aquifer in which the about 300 private wells and the community water supply wells are in, to hopefully reflect screen depth sampling. So the results. This is showcases the results for the Superfund site, which again was kind of up gradient of the kind of the hot zone, if you will. And as you can see, there was really no correlation. I ended up using a concentration of 15,000 and 2,300 days from initiation, and I employed the I employed the contamination and introduced it to the model via recharge. This area was a historical dumping area of hazardous waste, such as chlorinated solvents. So we wanted to ensure through this investigation that the PFOS was not coming from this area as it's actively undergoing remediation. The next area that we wanted to explore, again, up gradient of kind of our main data points, was a fire station. It had been around since the late 1970s or so. And as you know, there's AFFF firefighting foam is a huge contributor to a lot of PFAS contamination. So we wanted to see how that, the introduction of a recharge from that area would be reflective of our actual data. And as you can see, we had 45% or so R squared there, which was actually our best fit. And then the third data point, or source ID location that we wanted to explore, was an undeveloped field, pretty much adjacent to some of our sampling data points in this hot zone, so a little bit closer than the firefighting station. And this is actively being developed, and we were curious because it's Rockford and this industrial kind of past, whether it was a historical dumping ground or if clean fill was being introduced into the system and potentially contributing to the contamination. This also, we had a fairly low value at 0.2, so we were fairly certain that this wasn't the contributor either. Lastly, I wanted to kind of explore source identification for multiple sources, which included a nearby laundromat, in addition to the open field and firefighting station. And so the shape of this this result was more indicative and correlated with the geospatial results. But again, the firefighting station example seemed to work best. Also explored varying concentration in this particular model, and it didn't seem to be as sensitive as well. So, so this was the best fit, this potential source area 2, which is the fire station. Actually, if I removed our deepest well, the R squared would be 0.66. So potentially some corrections there in terms of the vertical hydraulic conductivity and some of those kind of vertical measurements. But certainly there's limitations to this type of exercise. But again, from a state agency perspective, looking to just use their best resources appropriately. This was kind of an interesting result. Certainly further investigation potential, such as performing additional soil and groundwater sampling in this locale, or looking at maybe PFAS forensics to kind of clarify whether this matches or not would be a great exploration moving forward. So conclusions, as you can see here, the groundwater model results more indicative of source area ID than concentration. These geospatial methods do appear to be validated by the implementation of the groundwater model. And so this very well could be kind of a simplified investigative approach employed by others to showcase rapid initial ID. And what we want to all do is hopefully limit exposure in the quickest way possible. So thank you very much.